So here's a graph that represents function f, which gives the height of the drone in meters t seconds after it leaves the ground. Decide which function is greater. All right, table 9, you'll start us off. So for number 1, is f of 0 or f of 4 greater? Table 9. F of 4. Do you guys agree? Cameron, get that out of your. So side note, because maybe some people weren't here, or maybe some people are really confused right now. What we are starting this unit with is function notation. So function notation, in short, is f of x equals y, where you have like this letter being the function name. So we're talking about function f. X being your input, and y being your what? So you know that this 0 and this 4 is an input because it's in the parentheses. You know to look at your x-axis for 0 and 4. This whole thing as a unit, though, gives you your output. So like my output for f of 0 is 0 because that's my y value. My output for f of 4, I mean, these aren't labeled, but you know that as you go up on the y-axis, what happens with the numbers? They get bigger or smaller? They get bigger. So, I mean, say this was counting by ones, right? Then the output would be 4, but we don't really know how they're labeling it, but we do know the output is higher, so it must be greater for f of 4. Questions on that? All right, so that one is correct. Table 1, what about f of 2 or f of 5? Okay, so let's see. The output for f of 2 would be here. The output for f of 5 would be here. So this one's more of a trick question because these are actually what? Equal. Neither are greater, they're equal. Because, and we learned this on one of the other lessons, whenever it's completely flat, there's no increase or decrease, right? So if this is my height in meters, that means the drone was staying at the same height level. Questions on that? All right. Then table 2, what about f of 3 or f of 7? Do any of you know the answer? Anyone want to take it? I feel like this is one of the more easy ones today. Okay, f of 3. Let's see. F of 3 would be here. F of 7 would be here. So yes, this is higher. Because you have to compare the outputs, not the inputs. The output for f of 3 is higher than the output for f of 7. Table 3, what about f of t or f of t plus 1? All right, anyone disagree with that? Now, I would agree if the graph was only increasing. All right, we have parts where it's increasing, staying the same, and decreasing. So if I were to plug in a number for t, there will be times where this is true, like that this is greater, and there's going to be times where they're equal, and there's going to be times where the other is greater. So it really, for this one, another kind of trick one, it depends on what t is. And also important to note, look what's happening to the 1. That's affecting the input because it's in the parentheses, not the output. Okay, so for example, if I were to plug in 5 for the t, so I have f of 5 and f of 5 plus 1, which is basically 6. That's not a t, that's an f. All right, we need to compare the outputs. So f of 5 is here. Let's pretend these are counting by ones. That equals 4. F of 6 equals, I don't know, 3 if we're estimating. This is a situation where f of t is greater than f of t plus 1 when the t is 5. Right, but again, there are going to be other parts where the other is greater, is going to be parts where they're equal. It really just depends on what t is. Questions on this warm-up? All right. If we were adding a 1 outside the parentheses, by the way, that would be affecting the output. And then, yeah, that would probably be true then, that would be greater than f of t. But since we're affecting the input, and it's not consistently going in one direction, it just depends what t is. All right, today we are on lesson 3 of unit 4. Sorry, I'm already planning for next semester. We're not in January right now. All right, anyway, we today are going to be using function notation to talk about situations. So describing connections between a statement in function notation and the graph, using function notation to represent a relationship between two quantities in a situation, and using statements in function notation to sketch a graph. I'm recording right now. You guys are pretty used to that because I typically choose this class to record in. So just know, like, you can always go backward. You can even go forward because I always include the ones from last year just in case, like, you know you're going to be absent. So they are there. Practice is in Schoology. And your first quiz for this unit will be Thursday. It'll be on the first 5 lessons. And then I don't anticipate the rest of these dates changing. Like you just saw, I'm planned all the way through the end of the semester. I'm starting to plan for next semester. So you do your job as a student and plan to be ready to take these tests and do well on them the first. Questions on that? All right. So then the next activity, new situation. We're going to be talking about smartphones. So the function P gives the number of people in millions who own a smartphone T years after the year 2000. First, you're going to tell us what each equation tells us about smartphone ownership. And then you're going to use function notation to represent each statement. So for question 1, your answers will kind of look like these. And for question 2, your answers are going to kind of look like these. All right, so using the information provided, be able to tell me what it means when it's in function notation and how to write something in everyday language in function notation. Question? I think 3 minutes would be enough. You have people in your group work together, ask me if no one knows. But for now, it's the same recorder until I change it. Everyone gets great. You know. So what does P of 17 equals 2,320 tell us about smartphone? So to interpret it, make sure you guys are saying something about what the input means and what the output means. I always tell you the units in the description. So table 4, what is that 17 referring to? Okay, well, that is one of the variables. The one that refers to the input is actually gonna be C for years. So when you are deciding, because it didn't say, like, it didn't have it in function notation to where you could see that T is the input, T is in the parentheses, so you just had to compare like years versus number of people. What is more dependent and what is more independent? I can tell you that time is almost always on the what class? Time is almost on which axis? The x-axis. So if one of them is a time frame of some sort, typically you can't change time. And then that means that the other variable, the number of people in millions, depends on what year it is, right? What do you say that makes sense? So try that again. Table 4, the 17 is what? And specifically year since 2000. So class, what year was that then? So your sentence, kind of in this format, if it follow, you would say in 2017, there were, would you guys say 2,320 people? Anyone else disagree with that? Does that sound accurate that in 2017, only about 2,000 people had smartphones? So that's where you reread the description. It gives the number of people in millions. So 2,320 million, which isn't really proper to say. So let's convert that. Converting can be hard, I get it. It's even hard for me to know how many decimals to move something and which direction. So what I'm gonna do is I'm gonna take that 2,320 and I'm gonna multiply it by 1,000,000. How many zeros is 1,000,000? 6 zeros. So I'm gonna multiply it by this. And the number is so big that it gives me it in scientific notation. I'm not sure if you're familiar with how that works at all. But the way it works is that since it's times 10 to the 9th power, I know to move this decimal 9 spots to the right. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. If you plan to go into like a STEM field, you're going to use scientific notation a lot. All right, and this is the number in more simple terms that you can recognize. Do you guys know how big that is when it has that many comments? Anyone? It's 1 billion. So it's 2,320,000,000 people that own smartphones in 2017. That sounds more accurate than just 2,320. So that's because they're giving it to you already in millions, okay? So I'm gonna copy this number onto that. Make sure that if you just put that there's about 2,000, I can fix it. Really, it's over 2 billion. Right? There were this many people who owned smartphones. Questions, comments, concerns, sense now. All right, let's pick up the pace on the next ones. So table 5, what about P of -10 equaling 0? What does that mean in this situation? 10 years before the year 2000, which you could say it just like that, or what year would that be? 19. So you could say in 1990, what happened? Okay, you could say there were 0 people who owned smartphones. You could say it just like that. You could say nobody owned a smartphone, because that is like the normal everyday language you'd probably say. There were 0 people who owned smartphones. So when you are interpreting them, probably mention both units. Questions, comments, concerns? All right, then table 6, you are now writing it in function notation. So for 2A, where it says in 2010, the number of people who owned a smartphone was 296,600,000. How would I write that in function notation? $296? Like that? Okay. So I do like, the function notation. If you guys say P of whatever, I know to put it in parentheses. But yeah, it will be 10 for the input, because 2010 is 10 years after the year 2000. Now let's see if this is the correct way to convert it in millions. So again, I was also not great at moving the decimal, like knowing how to convert it. So I just use a calculator. Same with how I times things by 100% when I want percent. I tend to just multiply to get straight. But in this case, we're kind of working smaller. So we're here, I had to multiply. For this, I'm gonna divide so that I can get the unit the way they want it. So I'm gonna type it in. We're going to divide that by 1,000,000. The 6 zeros. So this is what it should actually be. 296.6 million is the correct. So it's 296.6. So we just need a decimal here. And now it's perfect. Questions on this one? All right, table 7. In 2015, about 1.86 billion people own a smartphone. How would you write that in function?
We have 15.
860 or 16. Okay. So let's see. Use the correct function name. We're talking about function P, so that's why there's a P here. 2015 is 15 years after the year 2000, so that's good. Let's check to see that this is the right number, that they converted it to millions, right? If it's 1.86 billion, so how many zeros is billion? 9, right? So first, it's gonna look a little weird, but this is the only way I know how to properly do it. So first I made it the billion increment, because right now it's like 1.86 billion. And now I'm gonna divide this whole thing by 1,000,000. I don't know how you guys did it, maybe you know an easier way for you, but this is the easiest for me. Okay, yep, so good, we converted it right. Questions on how to interpret function notation, how to write it in function notation? Good. All right, now same situation, just a couple extra things about it, which we'll probably do together. So May is curious about the value of T in P of T equals 1,000. First, we're gonna talk about what the value of T would tell her about the situation. So that 1,000, is that an input or an output? It's an output. And I know that it is because it's not in the parentheses. It's that easy. All right. I know it's a Y value because it's not in the parentheses. And that we know for this situation that the Y-axis is, and it even says it down here, the population in millions that own a smartphone. So when it says, what would T tell you about the situation? What was T representing again? Yep, it's in the description, years after 2000. So what it would tell her about this situation would be the year after 2000. I don't know how to say it. The year after the year 2000. That this many people owned a smartphone. To use it in everyday language, because we don't normally say 1,000 million. I'm gonna take that 1,000 times it by a million. It is. And that, do you guys know what number this is? A billion. So we want to know, or what it would tell us would be the year after the year 2000, that smartphone ownership reached a billion. You could say a billion if you want. We can put the actual number, which was 9 zeros after the 1. But that is what finding that value would tell us. When exactly smartphone ownership reached a billion. We're not there yet to where they're giving us an equation and telling us to solve. They didn't give us an equation for this. But if that were the case, I would plug it in for the Y and solve for X, but we're not actually doing that here. What we are doing is seeing if 4 is a possible value of P here. So do you think there was ever a time in our history that smartphone ownership just like declined? Right? There's no like, I don't know, situation that happened that made us all lose our smartphones, right? So it's probably more likely that it just kept increasing over time. So what you are going to do, I would sketch the graph and then answer that question. So there are some coordinates that we know for sure based on the ones we already did earlier in the activity. Remember, function notation has an input and an output. So you should be able to know the coordinates from the ones we already did. So for example, one point that will for sure be on your graph is 17,2,300 points. You can plot this because it gave us that information. Each function notation can be converted to a coordinate because you should know what the X is and what the Y. So you're gonna plot these points on that blank graph you have on your paper and then answer the question. Is for a possible value for T. So those are the coordinates that you should for sure plot. We'll go over the answer shortly. I'm going to freeze my screen so that you don't just copy me in graphing. I hope you know how to graph. Okay, so raise your hand if you think that 4 could be a solution for that value of t. Raise your hand if you think it can't be. Okay, it's getting a lot that maybe just don't know. So when you plotted your points, the ones that we know for sure, because they gave them to us in the situation above. This is what your graph should look like. And again, we talked about it, like realistically, was there an event in our history that made smartphones go away? Right? No, they kind of just have gradually increasing over time. So if you use your graph to see, could the 4 be a possible value? That would be here on the graph. Do you think that it would go up and then go back down? So you could say no for that reason. You could mention this coordinate, the 10, 96.6, because in 2010, we weren't even close to it yet. But no, we did not reach it in 2004. That could be your reason. Now, one thing that we also look for is whether or not we should connect those dots. So ask yourself whenever that happens. Can you have a decimal of the year? Can I have like, I don't know, 2.5 years, 2.75 of the year? So yes, I can have a decimal of the year. Can I have, when they report the population, a decimal? They're reporting it in millions. Yeah, we even had it in this situation. So yes, I know you can't have a decimal of a person, but they will often report like in millions, 296.6 million people have smartphones. So yeah, you can. When that is true for both, then yes, you can connect the dots, because there wasn't ever a moment that either one had to be a whole number. So you can connect it and make a continuous graph, pretend that's like, it doesn't have to be perfectly straight. But you can connect them because of those equations. All right, questions on this activity, because now we're gonna present and all right. This next one about boiling water will be like your cool down. I'm going to give you more time than I normally would to give you try something. So definitely try it in that time frame. I will switch the recorder this next go around. So what you are doing, and you could write, it says discuss, but you should also write it down. You are given function W, which gives the temperature in degrees Fahrenheit of a pot of water on the stove. T minutes after the stove is turned on. You're going to take turns with your partner to explain the meaning of each statement and write it down. Listen carefully, and if you disagree, discuss until you reach an agreement. Then, if all statements in the previous question represent the situation, you're going to sketch a possible graph of function W. So same thing kind of like we did in the last one. Some of these, like with the equals, can make the coordinate. Some of them with the inequality, you can think about your warm-up, how you might not know the exact output, but you know it should be higher or lower on how it's going to. So I'm going to give you more time than I normally would. It's going to take you 10 minutes, but I'm going to give you 10 minutes before we go over the answers. When you finish that, you can work on your practice until we go over it. Questions on what you're doing? All right, so this is how you know that you know what you're doing. So try it genuinely, talk to your group, and then work on your practice until we go over it. All right, so you are saying what the meaning of each statement is. So table 6, what does W of 0 equals 72 say about the situation? Like 0 what? 72 what? Okay, good. 0 minutes, 72 degrees Fahrenheit. So when you're making your statement, you should probably mention both. All right, this basically says that, and you can say it a few different ways, but at 0 minutes, the temperature of the water was 72 degrees Fahrenheit. I'm kind of squeezing it in there. But yeah, remember we're talking about the temperature of water in a pot on a stove. So at 0 minutes, which is essentially when it started, it said T minutes after the stove was turned on. That was the temperature. Good. Table 7, what about when it says W of 5 is greater than W of 2? What does that mean? Okay, good. So at the 5 minute mark, the temperature was greater than at the 2 minute mark. Greater, higher, whatever word you want to use. Thank you. And then I had but yeah, that's what greater than means, right? It means that the W of 5 is higher than at the W of 2. Table 8, what about when it says W of 10 equals 212? Okay, good. So at 10 minutes, and I'm going to abbreviate, the temperature of the water was 212 degrees Fahrenheit. Do you guys know what that means? Anyone know what 212 means? It's a temperature of water. Good, that is the boiling point of water. Good. Put that in parentheses. That's when the water started with after 10 minutes. Table 9. What about when it says W of 15 is greater than W of 30? Okay. So maybe if this was an equal sign and this also wasn't like in function notation, I would agree with you. It definitely says something about at 15 minutes, the temperature of the water. Table 9, what symbol is this? Greater than, because remember the openings always face the bigger number, so if it's facing this, we're saying that at 15 minutes, the temperature of the water was greater than it was at 30 minutes. Is how we're interpreting that. Was greater than the temperature at 30 minutes. So what does that tell you about the situation of the boiling water on a stove? Why would after 30 minutes it not be as hot? What did they probably do? They probably turned off the stove. Maybe they lowered it, but at 30 minutes, it is less than at 15 minutes for the temperature. Table 1, what about when we say W of 0 is less than W of 30? What does that mean? Good. And that, how she said it, is great. You could follow the same format as we did earlier. But yeah, the water was hotter at 30 minutes than at 0 minutes. So even though they might have like turned it off or something, it's still warmer than when it started. And yes, the opening is facing the W of 30, so yes, the 30 minutes is warmer than the 0 minutes. Questions on interpreting, does that make sense? If we have the input and output, you should probably mention something about both. We only know the outputs of the ones with the equal signs. The other ones, we don't know the outputs, we just know that it's like higher or lower than another input. So then using those statements to make a possible sketch, you for sure should have coordinates at these two coordinates at 0, 72, so X and Y. And at 10, 2, 12, those are the only coordinates we know for sure. I'm gonna plot those. And know how these are counting by based on what these numbers are. Since it's skipping every other tick mark, each tick mark is how much? Good, so then this one right here would have to be 75. So 0, 72 would probably be here. 10 to 12. About here, the halfway between 200 and 225. Those are the only points we know for sure. The rest, you just know which are higher and which are lower. So that's more open to interpretation. So I know like my output for the W of 5 will be higher than the output for the W of 2. So I mean, I don't know, something like this. They just have to be higher than each other. So if I were to start sketching, that's trending upward. Right water gets hotter. We're trying to boil it. The other statements, we know that W of 15 is greater than W of 30. So here's where the input is 15. I don't know where exactly it is, but I know that it should be higher than it is at 30. And then W of 0 is going to be smaller than W of 30, which does match like what I said. And so a possible sketch of the graph can look like this. I mean, it might even be lower, who knows? But the only parts I know for sure, I accounted for. And I did make it continuous because can you have a fraction of a minute? Yeah. Can you have a fraction of a degree? You can. So that's why I connected the dots. There's always a temperature for each second, for each minute that it's going on. So you still have like more than enough time to put away your notes properly instead of just shoving them somewhere. And if you already had your Chromebook open, you can work on more of your practice instead of just waiting for the bell to ring.